Thank you guys. So we have the first presentation here from our friend Ralph Humberg, who is going to present us a very interesting topic, Tama's AI Avengers. Let's hear it, Ralph.
Very great, thank you. Hey, thanks for coming. When I joined this, or just entered this room here, I was thinking back of my first career days. At that time I started in Siemens, and we did kind of same things, right? We called it multimedia at that time, by far not artificial intelligence. And the first time I entered this office, it was just shabby. It was really an old concrete building, and I felt, okay, this is what we do now, the new stuff, and guys, you live in great times. So believe me, such a venue and working in such an environment is fun, and I'm happy to be part of that. So today I want to share a bit with you what we are doing on the AI side. We are actually in this business already for quite a while. We deal mostly with images. And when I say images, I don't mean a raster image in general. I mean everything and anything that the eye can see, right? So we use these images, we exploit them, we combine them, we fuse them, and we do a lot what we think is possible with a machine. And actually we combine a lot of the stuff in a machine, in a human context. So very often when going to conferences or seeing what the technology is doing, we certainly see big hype, a big media, a lot about deep learning, or deep learning being a special capability of machine learning, which is certainly all right, and that's all cool. But my experience is, well, that alone is not the magic bullet, right? It's cool, it's good, it does new things, but in our experience, it doesn't solve all the questions and problems that we have. So what we do a lot is combine actually these machine capabilities with, well, extracting knowledge, expertise from humans. We call it expert knowledge. And I want to show you a bit how we do that. And from our perspective, there is no need to decide between any of them. We just do them in parallel and infuse them. So, 3 topics for today. First of all, why we are big proponents of team play when it comes to algorithms and exploiting information stacks. And the second, before you start coding, I mean, not to despise what coders are doing. Of course, we need code in the end, otherwise we're not going to have an artificial system. But before, I do believe it's paramount to answer the key question. I'm going to come to that question. The question is simple, the answer is difficult. And I want to give you a few examples from the construction and remote sensing industries that are some of the industries we are in, right? Good. First of all, artificial intelligence, you may have seen some of these graphs, read it from the right side. There is very many different disciplines, and I know there is companies dealing with all of them. Our company, we are really just focused on images. We believe this is, well, it's the human eye in a way. That's a large enough business for us to entertain in. We certainly do deep learning, but not exclusively. We actually use a lot of classic methods in combination because we find it a lot more effective, straightforward, and leading to proper answers. And also we are not really busy, and this is why you won't see us with any consumer applications. Our business is completely B2B, or actually in the remote sensing side, a lot of B2 government, because that's a lot of governmental business when we talk to mapping agencies and anyone who's interested, for example, in satellite imagery. And what we do, or always what our interest is, we want to help decision makers. So that's my first key statement. We are not here, so Tama Group is not here to replace humans at all, right? So what we build is what we call decision support systems. We just want to make the subject matter expert, the domain expert, smarter, cleverer in what he's doing, and want to give him independent in what tool, typically certainly on a desktop or on a smartphone, capabilities to take better decisions. That's all we do, right? We're not interested in defense work. We don't do really anything on the consumer surveillance stuff. all we do is help experts to become smarter with their decisions on what we call assets. A few words before we go to the artificial side. I want to go a bit to the intelligence side, right? Because this is all of us. Hopefully we all are intelligent. Extracting knowledge from us, especially when it comes to the visual system, right? We talk about images. So we all see images, and the beautiful and the difficult thing is each of our brain actually construes the world in his own way, right? There is no, so Valerie's and my perception of the world is completely, partly different. And for all billion people on the planet, that's different, right? So we're working now for years, and how do we get actually access to tap into these brains? And there is different methods doing that, and well, I'm in that now for almost 20 years. We tried several methods, and we still keep on actually doing them in parallel, because we figured some work better than others, depending on what it is. So the first way we always did was, hey, here's the expert, here's the one who understands a bridge, here's the one who understands a farm prescription, or how to say, in the agricultural field, an agronomist who understands what to put on the plants. So the first way we did is we conducted a problem assessment. So a smart person talked to that expert, maybe to 10 experts, and tried to understand, what do you see in this image, or in a stack of images, what do you want to see, right? Are the sensors right you have? Could you use other sensors? So that worked well to a certain degree. And after that, we wrote the problem assessment down and had a coder start doing system work, right? So we had a system design. So far, so good. The only problem is that the one who's doing really the coding never really had access to the brain of this, the person who really understands what he's doing. So we're working still on that level here. One of the key tricks is here, now the human part kicks in. Most of us do not really like to talk about our own problems, right? So how do you really tap into, I mean, I recall we worked on the pharmaceutical side for quite a while. And after we worked for them large projects, a year and a half, then one of the key people came to me and said, Ralph, now we're gonna talk. Okay. You know, we have a problem with our key substance. This substance is a blockbuster. We have a problem here, and we see it in the images. This and that membrane grows faster, larger under these and that circumstances. I want you to find that. But by the way, the only consultant who's going to be on this project is this person, and the only other person who knows about that problem is you. That's it. And that very often is reality, right? When we talk about serious problems, most of these people are not really interested in sharing that freely, because in a B2B context, you talk about business decision, you talk about advantages and disadvantages of your business, right? So you're not so interested in sharing that freely. You need to find a mechanism to extract it in a way that the users don't feel offended or in a disadvantage. So we figured that, okay, that method works for a while. So we have done that for a couple of years, it was okay, but figured, we need something faster, something simpler. So we built a user interface for our platform so that a subject matter expert, a farmer, maybe someone, a civil engineer, could do the coding. So we built an easy-to-use graphical user interface, right? Click and point and draw in and pick algorithms out of a list. So we had a subject matter expert do the coding, which was cool, right? It worked because we didn't need so much access to the brains any longer. The disadvantage was, it's not really coded, right? So we still needed someone else who redesigns the system to make a performance system out of it. Worked well to a certain degree, got us further markets. And then certainly in the last years we saw beautiful developments on the machine learning and side. Hey, there is code, let the machine find better code in the code. We certainly employed that, right? Full agenda, all good. But we certainly also saw, hey, wow, there is a group of people now trying to throw this all away. Why do you really want to tap into these brains? Just give me samples, right? The expert show me in samples what you see, and let the machine do the rest. which we find today, in our experience, works pretty well in some areas. I'm going to explain later on in which areas. So in general, as a rule of thumb, this method works well as we see it for all the things we as humans see in 50 milliseconds or faster. Within 50 milliseconds or faster, I can see every face here. Very easy task for me, right? Can I see every face that has glasses on? Yeah, I'm still gonna be good in the 50 seconds. But there's a lot of more complicated tasks, right? Who is sitting close to someone who's younger or older than you? Oh, okay, all of a sudden the question is not that fast and easy any longer. So we figured for many of these things, we need different methods. And since we are dealing mostly in markets where decision making is important, right? It's not, as I say, it's not consumer market, it's business markets. We figured that accuracies of our systems are key important, right? In some areas, customers tell us 99% accuracy is insufficient. Forget it, we don't want to use an automated system that is just 99% accurate. On the consumer side, you would say, hey, if I have a cat finding algorithm and it's just 70% accurate, fine, it finds me any cat, right? So I'm happy. But if you are in a civil engineer or an inspector doing an inspection of a bridge, and whatever you say triggers a bill of $1 million or not, right? Then, yeah, 90% accuracy is just not good enough, right? So we figured we had to combine that, an automation part, because everyone certainly gets tired of sipping through terabytes of images, and we're adding really a manual part. So we try to combine these capabilities. Hey, let first the machine sip through all the data on the large context, provide it in a way that humans can comprehend it faster, so we call it then classifications on an object level, and let the human do the final thing, right? That includes QA, and that includes the signature. Because that's, it sounds trivial, right? I mean, who's signing a decision? But that's actually for the insurance in the end, and that's for everyone who's on the value chain afterward, the key question, right? I mean, who's signing that a diagnosis of a medical practitioner is correct? So in that way, we certainly circumvent that. Good, so key point for me is access to these brains is, to say the least, sophisticated. You may say complicated, demanding. And also, it makes a lot of a difference to which experts you talk to and how you ask them. So we had, when I was in the medical science side, we worked a lot with pathologists, right? And we had really a panel where we asked 5 pathologists about a certain task, right, that our machine was doing. And we got certainly 5 different answers, of course. And in the end, the discussion was that all pathologists then talked to each other why they were closer to the machine result, right? So, which told us again, right, this human perception is still so personal, right? That yes, we need to tune machine and capabilities to the human capabilities. So, for us, it's really we use artificial intelligence primarily for asset owners to take decisions. So in the end, that's the key medium we work with. Images, stacks of images. We manipulate them in many forms and shapes, right? So what we say, we ingest data. So we ingest classic raster data. We ingest point clouds, calculated point clouds, vector data, thematic maps from 10 different sensors. So sometimes our input stack may be 100 layers thick, right? So the only thing we require is that the what we call a geo co-registration, right? That a single pixel or a single point in the image is always the same position of the particular area, right? And in this case, yeah, that's kind of a satellite image, but we work with drone images to fly facades. We work with microscopy images to find changes on the geological side. So it doesn't really matter to us what kind of image it is. It just needs to be a stack of images. And yeah, these are kind of the methods we employ. So to give you a bit of a rule of thumb, in the way we employ it, right? I mean, that's the three major areas we're using. Yes, of course, machine learning, so from code to code. support vector machines, random forest, and whatnot. Yeah, all these methods we do employ, right? For the things we think they are successful. We do employ deep learning, as I say, for areas where that's what we currently experience, right? For things where the eye is fast. In the past, we did that with template matching, and we figured no, deep learning is a lot better. We're not yet so convinced, but maybe some of you can prove us wrong, that the deep learning approach is extremely strong with complex structures, right? Where even an expert has kind of difficulties explaining why. So recently we had a project where we talked to civil engineers, and we asked them, hey, it was a facade from a railway bridge, and it was wet in some areas, right? So there was obviously some water coming in or out from this building. And then we asked the experts, hey, we can certainly find all wet for you. And I said, that's not interesting for us. We need to find the particular water. And then I said, how do you distinguish the particular water from the not interesting water? Well, our civil engineer knows, because there is behind the facade, there is some outlets and this and that, but honestly he can't explain it. Okay, good. So that's the typical kind of problems you encounter in real scenarios when you do asset analysis. So, well, we employ it wherever possible. And currently, really, for complex situations, we have a human coder. We do a problem assessment. We talk to the experts. What I do a lot is really talk to people and interview, right? Really person to person. Like a medical practitioner, I ask you, what's your problem? And then I ask 7 times why, right? And that's really still a lot of our core business, right? And we write code. It could be in Python or C++, doesn't really matter. We write it in what we call ruleware, in a language called, well, object-based image analysis, but that's just implementation, right? In the end, the key process is we need to tap into people's brains without taking samples. We try to understand what the problem is by have an expert explain us in the image, maybe with background information, what makes a healthy leaf different from an unhealthy leaf, right? Which sounds easy, but in cases it's not. So, and that's here our work assumption at the moment. We employ what works best, right? So for structural knowledge, we typically employ the more problem assessment-based hand coding. For masked objects, yes, of course, the faster methods, and wherever we already have code, we certainly try with machine learning approaches to be faster, better, and more precise. I hope that helps you a bit in seeing how we tackle that. And in general, our experience is, yes, it is a complex field, right? Magic bullets are rare. So now I come to the key question before you start coding. And my experience is when you talk about images, it's a complicated question, it's a complicated answer. Very simple picture. I took that by a smartphone in the front of my office, right? You could do that in pretty much in Neuhauser Straße here, very easily. And then we built a bit of our code that was handwritten code, doesn't really matter. And I asked the coder, hey, please, find me the dirt here. That's what he did, right? If that's the most efficient implementation or not, doesn't really matter at this point in time. But then the more important question kicks in, what do you really want to find? And then I talked to a couple of people, and it really depends on who you talk to. If you talk to the chemical company who needs to erase this by a phone, they want to understand how many square meters are affected. So for them, area is the key number. If you talk to someone that, we should just replace the tiles here, then you have a different question, and you just want to find the number of tiles, right? How many of these tiles have more than 5% splash on it? If you talk to the insurance, they may be interested in, how many more cigarette butts are around this building? Maybe we've got to do something here. Very trivial image, already very different answers, and before you go to your coders, or before you do your session with your coders, you better have an answer to that, right? What do you really want to find in an image? Because the more complex images get, and you can imagine when you photograph bridges, right? Large structures, even agricultural field. It sounds easy, but it's not, right? These fields behave very differently when they are wet, or when they are dry, or when there is some harvest in or not. So that's for us always the key thing, spend enough time in the beginning with what we call the problem assessment, or the problem to be solved, right? So to share a bit of our work experience, yeah, that's industries we are engaged in, construction site, monitoring site, yeah, buildings, forests, fields, and certainly once this data is available, I mean the sky is the limit. Certainly we could change a lot. I mean these decisions could just open whole new arenas. I mean in some areas this is called precision farming, which is a big buzzword today, but then you talk to the people on the ground, how much precision farming do you really do today? How many euros do you spend on your precision farming program? Okay, well, we still do GPS to find the tracks. That's automated. That's not artificial intelligence, right? That's a GPS trace that helps the tractor or the farm machine to find its way. Fully automated, cool, but not artificial intelligence, right? So, of course, right, once you know exactly what's happening in the field, a lot of this stuff is possible, and yeah, that's certainly ideas. We go after predictive maintenance and interventions, and at the far end, design to real use, right? If you can trust that you know how your infrastructure is used, why do you build any spares in infrastructure, right? So you don't need that any longer. How many time? Just a couple of minutes? Yeah. Good. Cool. So I wanted to show a few business examples. That's from the construction industry. One of the engineering firms approached us and said, hey, we want to do a bit of construction site monitoring. Can you do that? So, yeah, of course it's possible. Give us some data. And this is situations what we find in the field very often. Data density is not that enormous. You get one image, maybe two images. It's a big image, right? It has yeah, gigabytes. It's very precise. It may go down to a millimeter resolution, but you may have one or two, right? So data sampling may get a bit of an issue. So, well, we typically start first with what do we need to see. And in this case, it was automatically finding the amount of gravel that was already laid, finding the cornerstones automatically, and actually we already found that some of them are already destroyed post-construction. And the most important task was, I think it was a geothermal facility, automatically find the valves and the tubes that are already installed. Because so far, someone has to send a person in the field and do the construction site monitoring. In this case, the question was, hey, could that be automated? But still here, that was, as the headline says, it's a feasibility study. One of the key things we find is the business case is not always trivial, right? Because if we like it or not, field stuff is not necessarily expensive, right? So, well, in Germany here we talk Mindestlohn. If you have someone cruising around in the field for 10 euros an hour and can perform certain tasks within a couple of hours, right? Your automated system got to be damn good, right? Damn comprehensive amount of answers it delivers, and your data acquisition has to be very cheap. In this case, drones are cool. When you do the real business case, right, of the daily flying, someone gotta go there, has to make sure that the drone does all the proper things. Cost becomes important, right? So that's why first on the scene, what we always do is really before we start coding, business case talk, right? How cost effective does this have to be? And then very often our conclusion is, hey, it's not worth 100% to go for 100% automation. We just automate 90%, and the rest is done by someone in an office on a very high level and just quick finish, right? If the machine does that overnight for you to find all these, how to say, candidates for valves and tubes, and a senior person in the office can finish it in 5 minutes. Perfect. Everyone says, hey, that's a good solution. So that's an area where we launch a product in this quarter. It's about building analytics. And in the same way, same thing, we package different questions into one, call it a toolkit or a capability. And it's all about images on the left side. One of our customers approached us, hey, it was in the Nordics countries, I didn't believe it, but they said, hey, we want to find illegal buildings. It's a municipality. Yeah. Well, why do they want to find illegal buildings? Yeah, of course for taxation, right? So money counts, right? And the red lines you see, that's the cadastral information. This is certainly a very particular example of where the cadastre is completely off with reality. And very often you find it all around the world. Building permits are, I have to say, given at a certain point in time, and after that they tend to be stretched, right? Someone is attaching a balcony, or someone is connecting two buildings and whatnot, right? And certainly municipalities are interested in raising taxes, right? So that's one of the applications we're doing here. And this is mostly, actually highly automated. Key reason is here that the aerial laser scan data is pretty good. And we can certainly compare with the ground truth, non-existing ground truth, right? It's just the vector sets of the cadastre. But we find it a cool application. If you come down to so you see here roof forms, for example, not exactly matching. You always have to ask behind. In this case, we did the analysis of the laser scan data. What you see here is the optical data. And they're not necessarily matched exactly. So in this case, analytics were done on other data than you see here, right? But the laser scan data in this case was more precise. Another one that we now do first projects for TÜV here. So offering building operators measurement tools. For example, you take a snapshot out of Google Maps, so you have UAV data, and you just want to have more complicated roof structures. And again, our answer here is semi-automated. We say, hey, it's a cool task to automate them all, but in the end, money counts, right? So we've got to come up with a system that is cheap enough. So in that way, still the building owner, well, he sees what he needs to see, and we give him or her the tools to, in this case, find enough space for photovoltaic, planning on a particular roof, right, your own roof. And that's another example we're doing. You see a bit of in the end, this is a heat map. We were looking at the large tower. The tower was 60 meters tall, and that image was actually taken by a drone. And the question here, again from a company doing inspections, was, hey, how many cracks are there in these bricks? And can you count cracks? Can you measure them? Can you identify large enough cracks? And that's what we're doing, right? So certainly you come up with a heat map, and after 3 months or 6 months, they are reflying and comparing if they have some heat sinks or some problems in the infrastructure. And here you see, that could be expensive decisions, right? If your analytics go wrong, right? So certainly important. On the remote sensing side, I don't want to say too much because in our experience, remote sensing is a very well-established industry. So our only business here is actually to provide tools. Our customers do all on their own, right? So one of our customers is Bundesamt für Kartografie, so a federal agency, the same in Austria, Bundesamt für Messungswesen. They use this platform all on their own. Well, we sometimes see results, but let's call it AI in practical life, right? So we are just a supplier of the platform, that's it. And we provide training. Everything else is in the remote sensing industry, as we see it already pretty advanced. So in that respect also, we needed to come up with different business models. So we provide tools for programmers. So the software we use is eCognition. For every company who wants to program on their own, that's what we do. But we figured not everyone wants to do it on its own. Some customers are just interested in having the application and not run it in the cloud, run it on-premise, have what we call an information factory. So they come to us, we build an information factory, they run it in their own premises, because as I mentioned in the beginning, some of the problems we talk about are very, how to say, demanding in a way, so not everyone wants to share that data. Or actually, most people don't want to share that data. And then, last but not least, we come to a cloud-based information creation center. We have not done that yet. We're going to start in the second half of this year, so that people who have no clue of programming, who have no clue of sensors, are just consumers of information, That's certainly, call it the Holy Grail. So yeah, second half of this year we're going to launch something here. This one actually I can keep very crisp. So we work across many different fields, not all fields, many different fields. We work across, well, pretty much everything we call a sensor. And in our experience, it's very difficult and actually not advisable to focus too much on just one image source. So certainly satellite data today is easily available. You can find a lot of satellite data and do a lot of sampling. But some of the questions you ask are, you just don't find that data there, right? Or the information there. So then we combine that with drone data or other in situ data. It could be a ultrasound sensor, right? In some areas, and we try to combine that. Good. That brings me to my last slide. Oh, time's good. 2 minutes. Perfect. Sorry. Cool. No. Okay, that's the last slide. So. Yeah, in the end, well, you know this old proverb, an image says more than 1,000 words. So in our experience, certainly also, if you have too many of these images, you're happy to have some tools that help you. And if you observe yourself, and this is what we do a lot in our business, we have to observe ourselves. How do we see, right? Once a pathologist came to me and he was really dealing with day-to-day cancer issues. And then I asked him, hey, why do you see that this is cancer, this is not? He says, Ralph, I have no idea, I see it. And certainly he has all these records over tens of years that he's right. Then he said, can't you observe me how I see? Right, because that's obviously the only way, because we as humans, I mean, we're trained on complicated and complex stuff over years. And after years we forgot why we know it, we just know it. And yeah, tracing back to that information source is of course, yeah, the power of imagery. And yeah, certainly some of the claim we bring to the table here is we want to help and support, especially with B2B infrastructures, to democratize the use of imagery. Cool, thank you. I just heard there is time for a question or two, if there's any. Happy to tune in. Yeah?
What is your understanding of AI? Is it just like machine learning, deep learning, or telling the machine how to learn, or is it really like cognitive, going beyond decisions, or more learning?
So I hope everyone understood the question. So what's our or my definition of AI, right? I take a very general approach to that. So same as I consider an image in a very general way. For me also the word what is artificial and what is intelligence, I take that very general. So we use everything we can get hold of, and we are not religious about the method. If this is really then machine or halfway human and halfway machine performed. For me, I mean, in general, the definition I like best was, if a task is completed by a human and required intelligence, and a computer does that task, that's artificial intelligence. That's kind of the definition I'm using, but it's far from being scientific or precise. And honestly, we talk more about the problem, to be honest, right? So what problem do we want to solve? And are not so religious about the definition. So if we find methods that are not AI but leading to the proper goal, we still take them.
Okay, so would you say the problems you showed are AI, or?
They require AI to be handled in masses, right? Yes. Yep.
How about the explainability of the deep learning algorithms you're using for your customers? Like, are they convinced with the explainability?
Sorry, say it again?
How about the explainability of the deep learning algorithms you are using? Are you facing like compliance issues or regulatory issues where you need to say why my algorithm or how it came to a conclusion?
If we come to regulatory issues and questions, we typically don't employ deep learning, right? Because when you have to provide traceability of your code, deep learning still is a bit stressed, I would say. So in that case, no, we use handwritten code, and we can explain where it comes from. In our platform, coding is very fast. So in that way, when it really comes to a regulatory scene, we would not use deep learning today. But as soon as this whole, how to say, proof that, or understanding how has the CNN really came to result, then we would use it, right? Today we have an alternative. Cool.
Thank you, Ralph.
Good.
Guys, we would like to thank all the sponsors and participants and the speakers for attending MI Summit, the one and only free event in Munich regarding artificial intelligence. It will become even bigger for the next years because we believe that the science should be hip and free.